Hi, quite interesting problem. This is in which a particle of mass 2m, means we can say initial mass of the particle before it explodes. If we represent it as m1, then m1 is equal to 2m. And it was at rest initially, so its initial velocity vi, that is 0. Now it explodes into two equal fragments. After explosion they move under gravity, means we consider these to be moving up against the gravity, both of them. This is the first one, this is the second one. Their mass is m2 and m3, and it is given that m2 is equal to m3, so that will be equal to m. Now maximum height raised by the first one, but first of all, using energy conservation, maximum gravitational potential energy of the fragment at the maximum height, it will be equal to its initial kinetic energy, half mv square. Cancelling this m, h will be given by v square by 2g. So for the first particle, h1, that is equal to v1 square by 2g, and for the second particle, means second fragment, v2 square by 2g. So the difference in the heights, if we consider v1 to be more than v2, then h will be equal to h1 minus h2. Taking this 1 by 2g as a common out, leaving behind this is v1 square minus v2 square, or we can say this h, that is equal to v1 plus v2 bracket v1 minus v2 and divided by 2g. We consider it to be equation number 1. Then using first equation of motion, Vf is equal to Vi plus gt when the object is going up, minus gt, as acceleration will be negative in this case. At the maximum height, Vf0, Vi minus gt, so time will be given by Vi by g. So time taken by the first fragment, v1 by g, and time taken by the second fragment, v2 by g. So the difference in time, again as v1 is greater than v2, so difference in time t1 minus t2, or we can say this is 1 by g bracket v1 minus v2. Okay, now we know impulse may be given as change in momentum. Change in momentum means final momentum of the system of the two fragments, m1 into v1 after explosion, v1 plus m2 into v2, that is the total momentum of the two fragments after explosion. No, this is m2 and this is m3, and minus initial momentum, that was 2m multiplied by vi which was 0. So for m2 this is m, this is v1, for m2 that is m, for m3 also this is m into v2, and that is minus 0. So it is given as, means impulse is given as, m can be taken out as a common, m bracket v1 plus v2, that is equation number 2. So finally, dividing equation 1 by 2, we get h by t is equal to 1 by 2g bracket v1 plus v2, another bracket v1 minus v2 divided by 1 by g v1 minus v2, cancelling v1 minus v2, cancelling this g, finally v1 plus v2 calculated to be equal to 2h by t. So momentum I, no sorry, this is not equation number 2, this is equation number 3. This is 3, that was actually equation number 2. Okay, so now using equation 3, impulse that is equal to m multiplied by v1 plus v2, and v1 plus v2 that is 2h by t. So finally impulse is given as 2mh by t, which is the answer for the given problem here, and this is the option C, which is correct over here. Thank you.